You might heard of Bayesian statistics or Bayes theorem or Bayesian probabilities. So basically, Thomas Bayes was an English statistician and a philosopher who lived in this 18th century. Basically, he was a Presbyterian minister. Actually, it's kind of special sect within the Christians. So he was a minister. A minister was somebody associated to the church, priest or something. So he's known for this Bayes theorem. So that relates actually the current probabilities to the prior probabilities. This is the picture of Thomas Bayes. Bayes showed how to use new evidence to update beliefs. So actually he was working on faiths and beliefs, and he wrote some manuscript which actually he did not present for any publications, though that work was later on restored by Richard Price. So the manuscript was titled as an essay towards solving a problem in Doctrine of chances, and where he gave some relations which nowadays we are using in order to find those conditional probabilities. So Bayes theorem is a simple mathematical formula which is used to calculate conditional probabilities. So it relates actually the current probabilities to the prior probabilities. So let's go and talk about what those probabilities are. Prior probabilities are they represent the best guess before we see the data. So we are expecting the data, but before that we have some we are having some guesses. So for example, you are interested in finding some number of fruits in some farm. So you might know the previous record of that farm. So before getting the fruits, you can give some guess that this much amount of fruits we will be getting. So that thing is called as prior probabilities or priories. And posterior probabilities or posteriores, or in other way of saying is, they are the probabilities derived from the data. So once you see the data, you get the numbers out of it, and then you draw those frequencies from that. So in that case, we call those probabilities as posterior probabilities. So here is the example. There is a hypothesis that a die is loaded. So posteriori in this case is that a probability of the hypothesis given data. So we see 3 sixes in a row, and then while looking into these 3 sixes, which is already given, so data is already given, and now you are giving your hypothesis on that. Okay, so you see 3 sixes and you suspect that die is loaded. So in that case, you get the data, and now you are deriving some probability. So that thing is posteriori or posterior probability. The other way, or the second form, is likelihood, where you can have a probability of the data given the hypothesis. So you know that your die is loaded, and now you are looking into, or you are guessing for how many sixes you will get. So what is the probability of getting 3 sixes while the die is loaded? So this is in comparison to the previous one. So you see 3 sixes, and now you are suspecting that your die is loaded. Here is the formal definition or equation for this Bayes theorem. So we have x while y is given by y while x into x divided by y. If you know 3 of them, you can calculate the fourth one from here in this equation. For example, here x can be that the die is loaded, and y is your observation. So that is your 3 sixes. So here is an example to illustrate that. So we have an occasionally dishonest casino that uses loaded die 1%, where a 6 comes with the probability of 50%. So you might not be familiar with these kind of examples, but this dishonest casino example is mostly used in our probability book. So what happens over there is that they can play with the fair die, and they can also use with the loaded die. So here is a situation where we have a loaded die 1%. So they, after around 99 throws, they change the die, and then once we have that loaded die over there, the probability of getting 6 is 50% or half of it. So we can draw the probabilities from this situation. So probability of getting a die which is loaded, which is P of D loaded, is 1 by 100, 0.01. And conditional probability, this is obviously the independent probability, and here it is dependent or conditional probability. So probability of seeing a 6 while die is loaded is 0.5. So we want to know the posterior probability that a die is loaded. and we observed 3 sixes. So how can we calculate that? So for that we can use this Bayes theorem. We can use the equation as P of x while y given by y while x into x divided by y. So we fill up the equation as per our data. So this is the thing in which we are interested. We want to know whether the die is loaded while we are observing 3 sixes. So we read it as P of D loaded while 3 sixes. So that will be given by this. It's the same as is equal to P of 3 sixes while D loaded into P of D loaded divided by 3 sixes. When we solve it, we get this answer. So we plug in the values and the probability is 21%. So what it shows to us, what we conclude from here, that seeing just 3 sixes, should we conclude that our die is loaded? Just look into the probability. So it's around 20%. So we cannot be saying for sure that it is loaded since the probability is low. But while using this theorem, we can calculate the probability of our hypothesis. So we hypothesize that die was loaded. While we solve this equation, we get up this value, and then while looking into this value, we can either confirm our hypothesis or reject that. So in this case, the probability is low. So Bayes theorem is a simple mathematical formula used for calculating conditional probabilities, and it relates the current probability to the prior probabilities.